Hello there and welcome to the channel. I want to talk about gRPC today. I was working with microservices for many years now, but for whatever reason, we always used REST API, even in the backend, to microservice communication. But at some point, I just thought maybe there is a better way, and I started discovering things like gRPC and modern tools around that, which are available now. And I tried this buff project, and I was really impressed. And I think it's a really nice way to think about building API and to switch to gRPC. So today we will talk about buff. We'll see how hard it is to use the CLI. We'll briefly cover the schema registry, and we'll take a look into a small application in Java and Clojure to build gRPC server and to execute gRPC commands, and also how to test that with WireMock. And WireMock has a nice gRPC extension, which could be really handy. So first of all, why buff? Because it tries to solve a couple things that is difficult in gRPC and protobuf. The first thing, it will have a nice standard CLI tool that you can use locally, that you can use in your CI/CD pipelines. It will check the quality of your schemas, because it provides a thing called linter. So you can basically run buff lint, and it will tell you that your schemas are not formatted correctly, or they are not like following the best practices regarding the naming conventions. And the second thing is that it helps with code generation. And I think in protobuf, the thing that stops people using it is this extra step that you need to run to generate your classes for your language, for creating the service, and to create the request response objects. And we'll figure out is that hard or not. But first of all, I was really excited by this blog post, which is saying the real reason to use protobuf is not performance. And I really agree with that. So we have our REST JSON APIs, and the JSON serialization speed, or like anything related to the latency of these requests, isn't that big a problem right now. So I understand that there are some systems when these milliseconds will matter. And yes, protobuf serialization is much faster, and gRPC is much faster in absolute numbers compared to REST and JSON serialization. But I think it's not the biggest problem in the microservice architecture. What is the problem with a REST API in the backend in microservice architecture? And the real pain is that there is no centralized or standard way to force the schemas. Yes, there is OpenAPI spec that you can like create JSON schemas, some kind of schemas on top of your API, but that's kind of it. It's not forcing the backward compatibility. You need to build something on top of that. And also, it's not helping at all with building clients, right? So what we have now in our Clojure microservices is that each service basically should know the expected structure from the API, and it's all implicit. So there are no client libraries. These schemas are not shared at all, and that's a big problem. And even if you share the JSON schemas, you still don't have good standard tools to help you with your code boilerplate that you need to write for the API communication. And yes, everything could be solved, but it feels like if you stick with REST APIs and you want to build these schemas, checking the backward compatibility, helping with the code generation, you're kind of re-implementing gRPC, but on top of REST HTTP protocol. So what is the alternative, right? So gRPC and buff. Basically, buff will help to build a centralized place where you have your API schemas defined, and it is basically a shift in the approaches, right? So now when developers of one team want to build a service and expose the API, they first of all need to write it in a proto schema, proto buff files that's agnostic to language, right? So, and they need to think about what will be the response, what will be the names of the procedures, etc. And then they can share the schema, and they after that can build the implementation. But at the same time, the clients can just pull this single source of truth and build client libraries. And also buff, if you use schema registry that they provide, can help with releasing and building the client SDKs. So you push the schema and you will get NPM, Maven, Go packages built and published. So your clients can just use them without knowing anything that they need to generate own classes and files from the Protos files. But even if you don't use the schema registry that they provide, you can still do that as part of CI/CD steps because the buff CLI tool basically generates code for you, and you just need to package that. So cool. Let's see a couple examples, and let's start here. So I'll share the main project will be this one. This will be a Clojure, but basically it will be some Java interop, not much Clojure here. I was just interested to see how bad it will be to do this Java interop. I think it's not that bad, to be honest. And yeah, so first of all, we have this proto subfolder in our repo. If we go inside, we have buff.yaml that basically defines a module in buff. And here we have two sections for the linting and for the breaking changes checks. And after that, we have ban.gen.yaml. And here we say that we want to use a gRPC plugin for Java and protobuf protocol buffers plugin for Java as well. If you have a multi-language system, you probably want to add more things here so you can generate client code for other languages, Go for example, or whatever. So what it means is that in the output folder, which is going up one level, and then src Java, there'll be our generated classes. And here we define our proto files, and the best practice, I believe, is to put them under some package name. So it will be com Android API v1, and v1 is important because it's one of the recommendation that your gRPC schemas are versioned. And let's say you have this v1, and then you not allowed to do any breaking changes in your request responses, which could be a bit limiting. And if you want to introduce a breaking change, you can just copy paste entire thing, bump the version to v2, re-implement that in the service, support 2 implementations, and then once your client are moved to v2, you can just remove v1. And also, if you are in development phase, so you have like a new service, and you're not quite sure what will be the API, but you still want to start building and maybe integrating with other services, you can do something like v1 beta 1, for example, and then use a feature in buff.yaml saying that you support unstable versions, and that basically means that if you have a regex button including something like beta, alpha, or whatever, it will ignore the breaking changes, so you will allow to move quickly in the development phase. But yeah, we don't need it so far. So okay, we have this. This is basically some standard protobuf gRPC definitions. So you have service, and this is our service. This RPC will mean that these methods will be available for the clients to call, and we need to implement them in the gRPC server. And then we define messages for request response, and I believe the recommendation is basically have like a method name, RPC name, and then for request it will be same name with request, and response will be same name with response. It feels a bit of boilerplate, but actually it will just allow you to move quicker and not breaking the compatibility if you want to extend these objects with some additional data without the need updating the major version of your schema. So I created two. One is add service, basically taking two integers and returning the sum. And I also have this hello service, which has a request of first name and last name and returning the greeting string. And there is the hello function. And first thing I want to show is actually we're inside the proto folder, and I can do buff -- version, see what version I have, yeah, and I can run buff lint, and it will basically tell me that, hey, the recommendation is to name it with Pascal case for whatever reason, and here I have like a low case, but it's just like a nice simple example of the linter. It can check other things as well. So to the code generation, right? I have these files already here. So we see in it's src Java, and there's a bunch of things generated. This is all code generated by protobuf and buff CLI tool. So what I can do is actually just delete this folder. It's now empty, and now I can just run buff generate, and it will build these files for me so I can use them in the code. So regarding dependencies, we have a bunch of from io.grpc, gRPC netty for the server, gRPC stub, gRPC protobuf, and some Java annotations that you need to compile those. Regarding the code, so we have a single folder here in core. To create gRPC server, you basically just want to use a server builder, and you provide port, and then you register your gRPC services implementations. Then you run build, you have this server object, you run start on that, and that's it. And you see here it's kind of like allow you to create more modular code, so you can have multiple services and you can just add them to a single gRPC server, and they will be all available on this port, which is nice. So regarding the services themselves, annoyingly in Clojure, you need to use proxy, I believe, because the idea is you want to extend the base implementation class that was generated, and you want to override your methods, because by default there will be something like unimplemented exception throwing from them. So the proxy helps with that. In the first vector, you provide the class that you want to extend, and then you have access to implementing the methods here. So we have just hello, and for the add service, we implementing add. As request response, we now have access to our generated classes from our proto schema. So we have hello request, and the output, the response of this method should be hello response. So to once we have this, we can get first name and last name, some Java interop here to get the data that we want. And after that, we're building the greeting string by just concatenating these two values. And basically, from here, you can start writing plain Clojure code without any knowledge about Java classes. The only thing that at the end you want to convert that into a hello response, so it's valid. And then at the end you call this on next or on complete on the stream observer, and basically gRPC allows you to create streaming, for example. So in simple case, we just want a single response, but yeah, you can also create a stream of events and send them from the gRPC procedure. So here we have implementation of build service and add service. We are building that. We are passing the gRPC channel, and the gRPC channel is, if we compare to REST APIs and HTTP communication, is something like HTTP client that you want to create first. It is pretty trivial here, so we just want a managed channel builder, and we have address, host, and port, and we're using plain text, and we're just building that, and that's it. And the reason here is I wanted to try, so let's say we have this hello service, but it will also call another gRPC from inside. You see, we calling one service from another just to try how the client code works. And when we start the service, we are basically creating the server right here, create gRPC service, and then we basically wait termination, and then we also register a future that will call hello function, hello procedure on the server with a bit of delay. So let's run that and see if that works. Lane run. Here we go, system started, and after 5 seconds there'll be a call to hello RPC. We then calling add request. You can see here we have a sum of 1 and 2 equal 3, and then we got the response from our hello function, and we got the greeting. So from the client side, we have this gRPC channel, then we create the hello service blocking stub, and on top of that stub we can just call hello request, and it will go through the wire. But from the code point of view, it basically looks as a function method call on an object. And yeah, for request, we're just using the request builder, register data that like add data that we need, building that, and response is also typed, so we have our access to the greeting message right here, get greeting from the response. So yeah, that's the simple example. The other cool thing that I wanted to try is how that simplified tests, because in REST API approach, as I said, a lot of time developer is just spending building these assumptions in the test. When you have like a service-to-service communication, you're calling some API, you need to build mocks, stubs, and each time in all the services, we're kind of guessing the format of the API. And this is really time-consuming. And in gRPC, we basically can use the same classes that were generated for the clients and use them to write tests. And a cool thing is that we can still use WireMock with gRPC extension for our test usages. So we have WireMock standalone and WireMock gRPC extension dependencies. We have our core test. First of all, we start embedded WireMock server on a dynamic port. And then this is needed for gRPC extension. So I'm basically saying that inside SRC Java, it will be looking by convention for the gRPC folder, and inside it needs this binary file that is basically a compiled protobufs that we have. You can generate that by running buff build and this command. So the name will be services descriptor, and as file descriptor set, you just run that and you'll get this file. You can copy it into your test folder, or you can just generate it straight there. Basically, you just need your proto files to run that. So when we have this set up, we are registering the gRPC extension factory, and then we're starting the WireMock server. After we have our WireMock running, we can create a WireMock gRPC service, and here we're using our WireMock, and then we're using our generated file for the gRPC and service name. So it basically is just a string saying like the service name that we want. And once we have that, we can register stubs, right? So here I say that we want to stub the method hello. And if we receive the request that has inside the first name Andrei, last name Fadiev, we will return the message with this greeting, hello from WireMock gRPC. And once we register this stub, we can create a gRPC channel to our WireMock instance. This is the port of embedded WireMock. And then we can just call our gRPC hello procedure, and we validating that the response is basically this thing. And we can run a lane test to actually validate that. So you can see we got the response, and we have every assertion, only one, passing. If I change something here in the stub, and if I rerun that, we'll have a failing assertion. Yep, as you can see right here. If I actually fix this, but I will expect something else in the first name, and I run that, I'll get an exception because this method has no stub that is matching. And you can see here it says not found, no matching stub mapping found for gRPC request. And yeah, so once you have this, you can then pass your mocked services into your system components, and you can run your system and just do your function component tests or integration tests, as you call them. So yeah, that's it, I think. Let me know what you think about gRPC and this example, and I'll definitely explore more, and if I find something useful or learn more about gRPC, I'll definitely share. But so far, I'm really excited. So yeah, that's good. Thanks a lot for watching. And as usual, please leave likes and comments. That really helps. If you want to support the channel, there is a Buy Me a Coffee link in the description if you want. And yeah, thanks a lot for watching. See you next video. Bye-bye.